Okay, good morning. So, I hope you learned something. So, we will have a discussion for the next 30 minutes regarding the. Can you hear me well? Can you hear me well? I hope you can. Okay. So can you hear me? Okay. Okay. Now, the difference. Remember, yesterday we talked about the electrolytic cell, how you have two beakers. And then the only difference is that it moves from one point. Before it moves from, let's say, from copper to zinc, the electron now it's going to move from zinc to copper. And we switch the anode and the cathode. So basically, that's it. But remember that we can also have an electrolytic cell using the same beaker. So if I have a beaker, okay, if this is your beaker, hold on, I think I need a better. So that's my beaker. Maybe I'll move this closer. There you go. If I have a beaker, then I'm gonna have here my battery. This is my battery. Then it's gonna get connected here. Okay? So it's basically a battery and two electrodes, the anode and the cathode, dip in the same solution. Now, the idea here is that if I have let's say, a molten salt. Okay. For example, what is my molten salt? Let's say KCl, which is actually liquid. Remember that when a salt is molten, what you have inside will be K plus and chloride. So meaning here, I got here K plus, the chloride, the K plus, the chloride, the K plus, the chloride. Everything is in solution as ion. Not solution, in the liquid phase. This is liquid, molten. Now, here's the thing. One of them will be attracted to the anode, and one of them will be attracted to the cathode. Which do you think will be attracted to the cathode? Muhammad El Asil, which one will be attracted to the cathode? Which one? Where's the eraser? Where's El Asil? Where are you? Cathode. 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 Oh, look. K plus chloride. Which do you think will be attracted to the cathode? It's the cation. Not K, it's K plus. So cation gets attracted to the cathode. That's actually where we got the name cation. Cation oil. So you're not really listen to the video. This is in the video. Cathode, cation gets attracted to the cathode. Cation to the cathode. The anion will get attracted to the anode. This is for electrolytic cell, huh? Why? Because in cathode, that would be reduction. Remember? Meaning K plus will be reduced, meaning it will gain an electron to form the potassium metal. Okay? And then the anion will be attracted to the anode. And this is oxidation, meaning the chloride will lose an electron to form Cl, 2 electrons. You get the idea? Cation attracted to the cathode, reduction. That's why the K plus has an oxidation state of +1, becoming 0. And then we have here chloride will lose electrons, will form Cl2. Therefore, we will simply we will determine what do you call this? The potential table. So if you have your reduction as will have reduction potential table. K plus an electron give me K. And that will be negative 2.92 volts. Okay? And then for chlorine, that will be, I'm going to flip the chlorine. So chloride, 2 chloride becoming 2 electrons plus CO2. And that will be positive 1.36 volts. Okay? Then we are going to add this up. We need to balance the electrons. So 2, 2, 2. So 2K plus 2 chloride will give me 2K plus CO2. And then the E naught for this one will be, so I have my here, 1.36, 2.92. So I have here an E naught of negative 1.56 volts. So again, so if you want, okay, I'm going to put it down so you can see. So you notice here it's negative 1.56. Why? It's negative 1.56 because this is an electrolytic cell. That's the reason why we need a battery to force this to happen. You see? It's easy. When you have a molten salt, you have potassium, cation goes to the cathode, the anion attracted to the anode here. Anybody? Anybody would like to, what metal do we use here? Do we use potassium metal? Oh, do we use what? Anybody? Oh, Albaisa. What metal should we use for anode and our cathode? Yes. Okay. Copper. If you put copper there, it will react. Remember, we don't want anything that will interfere. Of course, there's metal there. How can the electrons flow? The electrons cannot. Water? What? Hey, no metal. That's impossible. Test tube. A test tube is, you need a conductor. So we need a conductor. Remember, electrodes does not need to be part of the chemical reaction. In this case, you need potassium salt, K plus, and chloride. So we don't need. We don't need, the electrodes does not need to be part of it. And so the electrode that we're going to use here, the electrode, could either be, we use an inert electrode like graphite, because graphite is a good conductor of electricity, and platinum are just two of the most commonly used metals for electrolysis. You get it? So, what happens to the anode? Remember that the anode, and this is your cathode reaction. In the anode reaction, you produce potassium. Does not react. You would notice in the cathode, it's potassium. Therefore, if this is our anode, you would see potassium being deposited here. So you could see here potassium being deposited. You would see that it will be coated by potassium. Okay. So the inert electrode will be coated. So if this is the inert electrode, then inert electrode will be coated with potassium. Just using the metal depends on E. We should use a metal that does not react. That's the point. And that inert metal will be covered by potassium. Then, what can you see? What is the product in the anode side? Oh, sorry, that's the cathode. This is the cathode. So you would see the part that is dipped into the solution, you will form potassium. Okay? But this one is, let's say, platinum. Let's use platinum for our anode and our cathode. Okay. Next, what will happen to this side? The anode. What are we producing? Cl2. Therefore, here, you would see bubbles coming out because Cl2 is being produced. You get the idea? So you have, on the cathode side, you have potassium being coated here on the platinum, and then the chlorine is being produced on this side. So you see bubbling coming out of it. Okay? We use these metals because they conduct electricity. Yeah, that's the only, we need, electrodes are conductors. Remember, electrons do not flow in the solution. They can only flow through a conductor. That's why we need to dip a conductor into the molten salt. Okay? Without that conductor, nothing will happen. Okay? Are there any questions? Okay. So this is when you have one molten salt. Now, what happens if I have two? Okay. What if happens if I have two molten salt? Okay. So this is how it's going to work, huh? What if I have a mixture of KCl? Okay. So I'm going to have my battery again here. My power supply. Sometimes they call it power supply. Okay. Then I have here K plus chloride, let's say sodium, and then iodide. Sorry, that is your, let's say copper 2 plus, and iodide, and then potassium, and then chloride. So I have a mixture of copper iodide and potassium chloride here. Now, like I told you before, cation, the K plus and the copper 2 plus will go to the cathode. And the iodide and the chloride will be attracted to the anode. Now, here's the thing. Only one redox, one reduction, one oxidation, which means that they have to compete. So how do they compete? We will use their self, the more positive will occur. Exactly. We learned that from our video. The more positive will occur. So basically, okay, we call it possible. Maybe I where's my eraser? I'll just get an eraser. Possible cathode reaction. Okay. Possible cathode. So possible cathode will be 2K plus. Sorry. K plus electron will give me potassium. And copper 2 plus 2 electron will give me copper. Okay. And then we'll look into the what do you call this? The redox potential table. And check it out. So have here copper will be, where's copper? 0.30. So this is positive 0.4, and this is negative 2.92. So which one will react now? The potassium plus or the copper 2 plus? Which one will happen? Based on their E value. Anybody? Muad. Waiting for your answer. Muad. Copper 2 plus. Very good. Because this is more positive, this is the one that will happen. Okay? Correct. Copper 2 plus. Okay, let's go now to the possible anode reaction. Remember, anode is oxidation. We flip the one we see in the, so we got here I minus, will give me 2I minus 2 electron plus I2. And then the other one is 2 chloride minus 2 electrons plus Cl2. We already know that this is positive 1.36 volts. And for the iodine, where's iodine? There you go, is positive 0.54 volts. The chloride, exactly. Because this is a bigger number, so this is going to happen. So this is our cathode, and this is now our anode. So the overall reaction would be copper 2 plus, so copper 2 plus 2 chloride will give me copper plus Cl2. And then we'd simply add these two, so that's going to be, sorry, my bad. Oh, sorry, guys, my bad. My problem, I have a problem. I forgot to change the, hold on. This is going to be C2Cl minus, will give me 2 electrons plus Cl2. Did I change the, hold on, I think I made a mistake. This is negative 1.36. Guys, this is negative 1.36. So I made a mistake here. This should be negative. So this is going to be 4.28. 28 volts. So this one is even more negative. I made a mistake. I changed it. It's negative 0.54 volts. Now, which between the two will now be, yeah, it's going to be iodine now. Yes. So it's going to be this one. Okay? So when you add them, it's going to be copper 2 plus 2 iodide will give me copper plus iodine. Okay? And it will be negative 0.20 volts. This is now your overall reaction. Because I know it's poor connection, what can we do? Because what we're saying here is that if you have an electrolytic cell, expect a negative number here, isn't it? If you have a negative number, if you have an electrolytic cell, expect a negative number. That's it. So every time you actually given something, you have to, by the way, these reactions, these reduction potential reactions will be provided to you in the tests. By the way, there's a possibility that your international exam will be taken at home. Wow, that's the first time it will happen. We still don't know. It could be at home or it could be here in CPC. If I wrote a reaction, did I say cathode? Is it a problem? What's it? If I wrote all reaction, did I decide the cathode and anode? No, it's not a problem. You can write all your reactions, and then what if they equal to 0? If it's equal to 0, it will not happen. It's at equilibrium. Okay, what does it mean when you have a less negative? Remember, the more positive, if both are negative, like in this case, both are negative, this one will require less energy to happen. Okay? And therefore, you got this one will happen. So the less negative it is, the more it will happen, the more thermodynamically favorable. Yeah, because the less negative, the less energy is required. Okay? What require more energy? Which one? No, the less negative would require less energy. That's why it will happen. Compared to this one, negative 1.36, it requires more energy, and therefore we choose the one with the more positive or less negative. The midterms, we don't know yet. We still don't know if we're going to have midterms or no. No idea yet. But our midterms is scheduled on the 29th, so be ready anytime. Okay? Anything else? Because the rest of the time you will be working on your virtual tasks. More negative, more energy needed. Yes, correct. So you ask the question. For those who are done, remember that you could always go back to this YouTube video. Okay? You can always go back. So I'm going to save it until, at least during the virtual day before I take them down. So for those who are done, you can now start working on your virtual tasks. Okay? So everyone is accounted for. When is the deadline for the task? It's 10 o'clock. You can do it like in 5 minutes. The task can be done in 5 minutes and we're done. Mister, for the anode reaction, we choose the more, in both anode and cathode, you choose the more positive. In both anode and cathode, remember, E naught is a measure of thermodynamic favorability. The more positive the E naught, the more it will likely happen. Okay? So is the E for the homework negative 0.1? I will not tell you. I will tell you later when I'm checking it. Wala, agree with Jindan. We miss you, Mr. Oh, chica. We call it in Filipino, chica. Meaning joke. Tomorrow is your birthday, Badrani. We should be celebrating. Happy birthday. So we'll have a celebration, the virtual celebration. Okay. We missed the labs. Yeah, too bad. We're supposed to have labs today. We probably need, I'll just probably be demonstrating the lab in the future. Did you check the assignment you gave me 0 in? Not yet. Terms, yes, the same coverage. We have to celebrate with Badrani. Yes, we should. Bring the kabsa. You post when you melt and with what use different e-cell of water. Why? What e-cell of water? Did I? With water, you choose. There are only 2 reactions for water that you should be choosing. You should be using anode. This is the one you use for water. Where is that? There you go. Where's the other one for water? Oh, there you go. (2OH minus). So that's going to be negative 0.83. And then the other water. So every time water is involved, you have to use that value for water. That one. Anode, cathode for water. Okay? The anode and the cathode. In the test, you will be provided with the anode and cathode reaction. Okay? Okay. So tomorrow, so we're done with electric chem. So our schedule for tomorrow is just we're just going to solve problems. Okay. So we'll be using Zoom tomorrow, or maybe YouTube, depending on which one is more important. Stay home. Stay home. They're shutting down Aramco soon. There are no more restaurants in Aramco you can only take out. Okay, who knows? We might be working at home. We don't know. So stay there. Zoom is better. I know. I think Zoom is better but it's also better. So we'll use both Zoom and okay. We'll use both Zoom. Okay, guys. Any more questions? Because you need the time to actually work on you have 1 hour. So if you can finish at 9:30, then the Kings is closed. Yeah, it is. Okay. Are we good? So, okay, I'll give you 1 minute. If no one's going to ask a question in 1 minute, then I'll be ending the stream. Your attendance is checked, so you can now work on your tasks. The deadline is 10 a.m. Everything is clear? Okay. It's not that bad. I mean, this topic is not that bad. Okay, stay safe, sir. Stay sage. Okay, bye-bye. See, this is what we had before last year. If both reactants and products are aqueous, what do you mean aqueous? If it's aqueous, you need to include water as your possible. So you need to include water as a possible anode and cathode reaction if aqueous. There you go. So meaning, for example, I have here, okay, just a little thought. For example, you have here aqueous potassium iodide. If I have aqueous potassium iodide, yeah, our hoodie is better. I know it's a better, yeah. So for your cathode, you'll be your K plus and then water. For your anode, I minus and water will compete. So that will be your competition. Okay? So K plus and water for cathode. So every time it's aqueous, always include water. Okay. Okay, guys? Are we good? Jindan, I miss you all. The lawyer. The lawyer. Oh gosh, how is your, what do you call this? Your end of year gathering? Durabe. Okay, guys. Okay, Kalas, huh? We'll wait for your reply. Okay, bye-bye.